Okay, so in this section of the module, we're going to look at how we can change our approach to database design so that we better split our data across our microservices architecture so that our databases are in line with microservices design principles. One approach to database design which leads to a tightly coupled monolithic database is when you design the database first, when you design the data first. And unfortunately, this data first design approach is quite common because it's traditionally been the way to design a database. And this data first design approach has always involved sitting down and working out all the possible entities that your system requires and the relationships between them, and then normalizing the entities using a normalization process. And you end up with a monolithic database because you try and create entities for every single scenario you can think of. And because this approach leads to a large monolithic database, which is gold plated with loads of entities and relationships that might be necessary or not necessary, this approach to database design is seen as a microservices anti-pattern. The data first design approach to database is almost the equivalent of creating monolithic APIs, which overall means it's the opposite of what we're trying to achieve with microservices. There's also a risk with this approach where you end up creating services which sit on top of these data first designed databases that are basically anemic CRUD based services. Anemic in the sense that it lacks proper business function and business domain, and it's more or less basically a service which sits on top of a database to create, retrieve, update, and delete the entities within the database. And you're even more likely to expose the internal entities, the entities within the database, as entities which are part of the external contract of your service. And this is because data first design doesn't really focus on the function or the role of the eventual service. The service basically ends up just exposing the internal data structures because there's no functionality to wrap around these data structures. And this is why when designing databases for your microservices architecture, we need to take the function first design approach to ensure that all our components within our architecture are loosely coupled and not tightly coupled because they all share the same database. The aim of our microservices and their databases should not be just to share data. We instead are trying to create microservices that represent a specific business function or a business domain. We instead have services that are more than just CRUD-based operations for entities they represent. Instead, we end up with services which have interfaces that provide a function, and that function is defined by the scope of the service. And to ensure that our service and the underlying database for that service represent a business function or a business domain, we need to take a top-down approach to our database. So by this we mean we need to define the function of our service and application first before we even think about designing our database. And we do this by using a domain-driven tool called bounded context as a design tool to design our service and its function. And this technique will help you draw a boundary around your service so that your service only has one function, i.e. one responsibility. And as part of this process, you'll also define exactly what models are required by the service, which need to live within the boundary, within the bounded context of that service. And defining these models is what defines what goes into your database, into your micro database for that microservice. In fact, as part of this course, there's a module titled How to Scope Microservices Using Bounded Contexts, which will help you achieve microservices that represent functions and models which will form your micro database for your microservice. Even when we take the function first approach, we need to ensure that our microservices have external contracts that represent the models required for the contract, and we just don't end up exposing the internal models used for the internal database as part of the contract. We want to ensure that we don't couple the internal workings of our microservice, which includes the database, with the external contract which our client applications consume. This is because if we ever need to change the internal workings of our microservice, we don't want to break our consuming applications, because we also end up changing our contract because the internal workings have changed. So keep internal models separate from your external contract models. In order to support our function first approach to database design, there are other techniques and approaches which can also indirectly support our function first approach. For example, code first approach to database design basically involves coding the models first within your code and then using frameworks to support the code first approach to physically create the database in the background. So for example, in .NET, I can take the code first approach to code all my models, and then using Entity Framework will just generate the database for me based on the code first models. With the function first approach to database design, we should also let the function of the microservice dictate what database technology we use. So for example, with the data first approach, we might have always ended up using a relational database system because we're defining entities and relationships between them. But with the function first approach, if we define we have minimal relationships between entities and it's actually all about performance and reading the data, we might end up choosing a NoSQL data store instead of a relational data store. So our conclusion for the approach to database design for microservices architecture is to use design techniques like the bounded context and technologies which support function first for database design in order to implement your microservices database.